This is the second part of the first part of energy balances. And in this very brief lecture, we are going to look at using tables of thermodynamic data to get enthalpy and other relevant process state values. So we've already looked at this diagram, and in particular, we are interested in water. Okay, so we're looking at water here, and the information is from the steam tables. What is underneath the phase envelope is saturated steam. It's got saturated vapor and liquid in it. And what is to the right of the phase envelope is all vapor. It is superheated vapor. And this we find on the steam tables. This table is table F.2. It's actually the superheated tables. Okay. This is actually the table from your thermodynamics book, but you have another table in your material and energy balance book that has the steam information on it, and it looks identical to this. All right, has the same units. The volume, this is specific volume in meters cubed per kilogram. We have internal energy U and enthalpy in kilojoules per kilogram. Your table does not have the entropy data, but we don't care about that until next semester. So what we do look at here is, since these are the superheated tables, what we have here, notice that the far two left columns are actually saturated liquid and saturated vapor, which is very helpful because it provides the saturated values in terms of pressure. So notice here, what is this number? 6.98. That is the equilibrium temperature at which the steam is saturated at 1 kilopascal. So if you pick the pressure and it's saturated, the temperature is given. It's like it goes with it. You can't pick that it's saturated and pick both pressure and temperature. You don't have enough degrees of freedom. So here we show you, though, if you have superheated steam, okay, this is not superheated. This is superheated. And in these superheated values, you can pick. Here's the pressure, and here's the pressure, and here is your temperature. You can pick. Because when it's superheated, you have only one phase present. And therefore, you have another degree of freedom, whereas when you have saturated, you have two phases present. So when you need information, you pick. So whenever you find enthalpy data on a table, there is a reference value because enthalpy does not actually have absolute values. So if you look it up on a table, that means it's relative to some arbitrarily chosen reference state. Okay, it could be, for example, 25 degrees C in the ideal gas state at 1 bar of pressure. That could be your reference state. But that's not the reference state on the steam tables. So I want you to find the reference state on the steam tables, and we'll discuss that in class. It's not 25 degrees C, I'll tell you that much. All right, so enthalpy is only really zero at absolute zero temperature. Okay, so when we're dealing with real values where we live on Earth, this is very unrealistic. So usually an arbitrarily chosen reference state is picked, and then all the tables on the all the data on the tables is in reference to that state. Okay. So, are you ready for your video quiz? Superheated steam. Okay, so you're going to have to look up the data. Superheated steam at 500 degrees C and 330 bar is expanded in an adiabatic turbine to 10 bar, and the product is all saturated vapor. If the feed stream is 15 kilograms per second of superheated steam, what is the power output of the turbine? All right, so what information do we have here given? we have two pieces of information about the steam at the starting point. So we have steam going in to the turbine, okay, and it is 500 degrees C and 30 bar. Can you find that on the steam tables? Yes, you can. H is equal to what? All right, and this is expanded to 10 bar, okay, 10 bar. I haven't given you a temperature, but I told you that's 10 bar and it is saturated vapor. And remember what I said when I was showing you the table, that if you know the pressure, then the temperature goes along with it. So you don't need the temperature. So you can also find the H value for the outlet here. Okay. So you can find the inlet H and the outlet H on the steam tables. And I'm telling you that the flow rate is 15 kilograms per second of the superheated steam. What is the power? What is power? Power is equal to m dot delta H. Okay? There's the m dot, 15 kilograms per second. Delta H you're going to find by getting it on the steam tables. And then you're going to solve for m dot delta H. What are going to be the units? Okay? M dot is in kilograms per second. And delta H is going to be in kilojoules per kilogram. So what does that give you? Kilojoules per second, which is kilowatts. All right. Okay. Good luck.